Hello everybody and welcome to this video. The purpose here is to set ourselves up for actually being able to do click to walk. So what we'll have done by the end of the video is we will just have something called a raycast, like firing a laser through the scene. And if you look in the console there, it'll be telling us when we're hovering over something walkable, for instance, which we've tagged a load of this world as walkable. And it'll also tell us when we're hovering over something that it can't resolve, like this gray, and it'll be logging out raycast end stop, which you can see that it's doing there when I hover over there. So we'll be looking into the game world and seeing what we would hit if we were to look straight through the cursor position. So let's see how that's done. I've just watched Rick's content and I think he did a great job, so thanks Rick for all that. It's looking really cool. I love the idea of having this image in the background to remind us of where we're going. So the first thing I'm going to do is get off of Rick's scene and into my own scene. As we'll see much later in the course when we get into version control and collaboration, if I make changes to Rick's scene now, he's not going to be able to work simultaneously on that. We'll have a clash, whose changes are valid. So I'm going to get straight into my combat sandbox. And I'm going to start this video by explaining raycasting to you. So here's my little lesson plan. And we're going to start with raycasting explained. So I've made you a little slide here. It shows that the basic point of raycasting is a bit like firing a laser into your scene. You're doing a visibility query. From the camera, in our case, we're going to fire into the scene and we're going to see, do we hit an enemy in the first instance? And if we don't hit an enemy, maybe we hit a walkable surface like the ground or a block we can walk on. And we're going to also, for reasons you'll see later in the code, going to introduce the concept of an end stop. But you'll see that as I review the script that we bring in. So basically just fire a laser, see what we hit is the bottom line here. Alright, so the first thing we're going to need to do to make that work is assign layers, and it is important that we use layers for the raycasting. So let's pop into my scene. By the way, Rick got rid of this free look camera, so I'm going to delete the free look camera. I'm going to delete the entire standard assets cameras subfolder because we're not using it anymore. And I'm going to go ahead and place my camera arm in here, right at the top there. I'm also going to tidy up quickly with an empty and make an environment. I like to reset my transforms of these empty objects before I put anything in them. And there you go. All right, so we have this environment. Oh, I didn't name it properly. There you go. We have this environment organizer. In fact, I could even put the ground in there. So that's looking a lot tidier. We just have a camera, player, etc. Let's just see how we go. Well, I'm using WSA and D to move around, and that's all absolutely fine for now. Great. So let's move on and start thinking about how to assign these layers. Well, the things that we want to be walkable are this, this, and this. Ultimately, of course, we're moving here towards being able to point to click to move our character. That's why we're doing this. We want to be able to click somewhere walkable, like up here, and have him walk towards it. Whether that's in a straight line or using pathfinding is going to be partially your choice for your project. We're probably not going to use pathfinding. We don't know yet. We'll see. But these are the things I want to be walkable. The main ground plane and then these few here. It's a bit confusing, so I'm going to do these three first. Layer. Now we don't have a walkable layer. Don't use tags, use layers, and you'll see why a little bit later on. So we're going to add a layer, and I'm going to make a layer 8 walkable. They're internally stored as integers, which is quite interesting. And you'll see that in a second as well. And then let's make one more called enemy, just so that you have some contrast. We're not going to be using enemies in this particular video, but it gives you some contrast, something to compare against. Okay, so we have a walkable layer and an enemy layer. So I can assign these blocks to walkable. And do I want to change the children of the blocks? It doesn't really matter. Let's just go, but I'm going to cancel for a second and look and see what the structure of these are. Okay, they are a block major object with a cube sub-object. So the point here, when we do the raycasting, it's going to be doing that and hitting colliders. And the collider at the moment is on our child objects. We may change the way this works later. So the basic point is, yes, we do want to change the children. So we're going to add the enemy to all of these blocks and their children so that the items that actually have colliders, i.e. these cube sub-objects here, are also tagged with layer because they have box colliders. Final thing I'm going to tag is the ground with walkable. And there you go. We've got everything we want walkable. In my case, I don't want to be able to walk there. So that's the first step. We have assigned our layers for raycasting. What we're going to do now is go ahead and import the camera raycaster.cs asset that we've provided you. So go to the downloadable resources for this lecture. You'll get yourself a zip file here. Oh, that's looking a bit funny. Let me just go to, say, details. So you'll have a zip file named like this. Let me just talk about the naming. This is lecture 9 of this section, which is combat moment, and the course name's RPG. So it's just a meaningful naming convention for us. And you need to unzip the zip first, typically, to just get the camera raycaster.cs script in. Great. So the moment that happens, you're going to get an error. It's going to tell you that in line 5, I think, of Camera Raycaster, it's using a enum, an enumeration, which we've covered before in things like the Unity course, the Complete Unity Developer, called layer. So we better sort that out immediately. I don't like red errors. So what we're doing here is we're just assuming that we have an enum available called layer. So let's go sort that out right. Oh, that was a nasty S sound. I apologize for that. Let's go sort that out straight away. So let's go ahead and make ourselves a script in Assets, a new C# script, and I'm just going to call it actually, I'm going to call it, what should we call it? Utility for simplicity for now, and to prevent you getting confused. It's going to be a utility C# class that it's just a script actually, not even a class, that we're going to use just to store an enum in for the moment. And we'll use more of this probably later. It's a useful utility class. So we're going to say public enum layer, not layers. Why not layers? Well, simply because if you look at the way that Camera Raycaster is going to use it, it's going to say, and we'll review this code in a minute, it's going to say layer hit equals layer dot. And you could say layers dot, but it just reads better if you say layer dot list, layer dot that. So we're going to make an enum called layer. Okay, and then we're going to assign some values to it. Now, why are we bothering? Because we don't want to be integer referencing these things. It's bad enough that the editor already internally integer references these layers. Walkable becomes layer 8. You've got a string here and an integer there. So I want in code to be able to actually get autocomplete. I want to be able to say layer dot and it fills out walkable, enemy, etc. So one off, we're going to map what it says in the editor here, walkable, which is integer 8, layer 8. So we're just going to say walkable equals 8. And we're going to say enemy equals 9. Now, if we do that and save, then of course I need to be using commas, not semicolons on the end of these definitions, just a single comma. It's the same as doing this. So the enum has the elements walkable equals 8 and enemy equals 9. Right, so hopefully you've seen enums before. It's just mapping, in this case, an integer to another integer. Actually, walkable will be stored behind the scenes as 0 almost certainly, but we don't need to worry about that. We are just saying that there's a way of getting hold of walkable through autocomplete. So when we go to Camera Raycaster over here, we can see that it's no longer complaining. We can now say things like layer dot and it says enemy or walkable. That's why we did this. So what I need to be doing now then is reviewing with you how the Camera Raycaster code works. Now, because this is a big complex project, we're not going to be writing every single line of code. That will be crazy, but we will be justifying all the code and modules we bring in. So let's talk about what this does. Public array of layers called layer priorities, and then it's initialized to a couple of default values. So let's see that in process. If we take the Camera Raycaster and drop it on the camera arm, please fix compile errors. So layer does not contain a definition for raycast end stop. Okay, so we talked about needing an end stop. Let's go ahead and put that in the utility class here. We have a walkable layer, an enemy layer, and just a programmatic end stop. Now, what did it call it? Raycast end stop, like that. Okay. So we're making you do this bit just so you've got some hands-on, and I'm going to make that equal to -1 because that's saying that this is something that's absolutely got the lowest priority. So -1 is the lowest priority. So the reason we're making you do this bit with utility is we want you to get some hands on this thing. Okay, so now I've defined my enum. Let's go and see if the Raycaster will work. There you go, that error's gone. Let's look at the camera, and you should be in a situation in a minute that you can drag Camera Raycaster onto the camera arm. There you go, and you've already got a layer priorities pre-populated. You could change this and you can select from what we've defined in the code, but you have a list of layer priorities. Now, maybe we change the architecture of this later, but right now this is fine and is going to work okay. Cool, so we have this Camera Raycaster thing. What is it going to do? So this just initializes a variable length array of layers that tell us the priority. Remember the slide? We're saying that the highest priority is enemy, because if you click on an enemy, you don't want to necessarily walk to him, but you want to attack him, or the system wants to know at least that you're going to attack him. In fact, shortly we're going to be introducing a sword when you're hanging over an enemy versus a different cursor when you're over walkable ground. The next priority is walkable and then the end stop. So that's the priorities. Now, we're also going to say eventually there is a distance to background or a max raycast distance. Now, we could make that public. There's no harm in making that public. Or better than public in this course, let's use serialize field. Now, what does that do? It keeps it private. And of course, they use the American spelling. It keeps it private so that other classes can't set this distance to background, but it will still show in the inspector. Let's see that. Let's save it, and we'll just watch the inspector. Distance to background 100, okay? And that's in meters, but everything's going to be in meters at the moment, so I think we'll leave that without any further justification. So that's saying if you get as far as 100, give up. That's what we're saying there. And then we go find a camera called the view camera. Then we're doing another interesting new thing here. We're defining a member variable called m_hit, and it's of type raycast hit. So when you do a raycast, which you can look up in Unity's docs, we also do it down here with the physics raycast, what it spits out is something of type raycast hit. It's a relatively rich type that gives you a lot of information about what that laser beam hit. So we're defining a member variable called m_hit of type raycast, and then this thing is called a getter, in case you haven't seen it before in C#. What this does is, rather than writing a new method that says public get raycast hit or get hit, this says if we do things this way, we can now access from the outside the property hit. So we can say camera raycaster, an instance of it, dot hit, and it'll tell you what it's hit. So this is a getter. Public raycast hit makes it publicly available. The word hit, and that's the getter. It just returns the member. It's a straight path through. The same thing here with the layer hit. So the general pattern of this camera raycaster is that every single frame, every update, it's just going to do the following. Look at the green to start with. It's going to look for and return priority layer hit. So it's going to basically find the highest. It's going to look through all of the layers in the layer priority list. It's going to raycast for the layer. If it finds something, it's going to set the hit in the layer member variables of this class, and then it's going to leave. If it doesn't find anything, then it's going to form an artificial hit with the distance member set to the distance of the background. So if we look at m_hit, because it's of type raycast hit, it's got all this stuff. Barry center coordinates, collider that it hit, the distance it hit, all this stuff. All we're interested in is saying, let's make an artificial hit come back. We're just saying, well, we got to the background. We got as far as the background, and we set the layer to end stop. So that's saying we hit the background in code. So that's what we're doing. That's what it does every update, and it sets its own member variables every update. You might be saying, do we really want to be raycasting every single update? Well, yes, because the player is going to be frantically moving their cursor around all the time. You could argue that when they're using controller, you want to turn this stuff off, and that's an optimization we could make later if we worried about it, and if we get to that. But for the moment with the mouse, yeah, sure, you're going to be moving the mouse, so it's going to need to update every frame. May as well update it and store that data. Now, this is caching. It's caching the result of the raycast, and caching can cause problems, but as long as we're aware of that, then it's good. All right, so what have we got? Let's just zoom out again. We've got an array of priorities. We've got a few member variables. These two have got getters with them. On the start, we go and find the main camera. That's incredibly standard Unity stuff. So let me just recap what that means. The camera raycaster will go and find the camera. Why does it find the camera? Because not by looking for other components, but it's just using a static property of camera, the class .main. So this is an easy way of getting the main camera in the scene. Provided that your camera here, which is in there, is tagged main camera, you'll be fine. So it goes, gets the camera, does what we talked about in update, and then there is a little bit in here. Look, var hit equals raycast for layer, and then the layer coming in from the layer priorities. So it just loops through the layer priorities. We need to understand a little bit about how raycast for layer works, not in great detail. We need to let go of the very bottom level of detail because we already know what this main loop does, and we can kind of trust that this works. But because you haven't seen raycast in any content I've taught recently, I want to just briefly run through it for you. So what we do is we form a layer mask. Now, you need to see Unity's docs for how that works, but you basically turn the layer into an integer, which is super easy because it's already represented as an enum, which is basically under the hood stored as an integer. You then do a bit shift with 1, and this is just because this is how Unity's doc says to do it, and that produces you a layer mask. It's because it's very quick on a hardware level to do this, right? So you form this layer mask. Don't ask me why it's this way. Well, I can tell you why, but it's a bit technical, a bit boring. But we do what we're told. We form a layer mask. Then what we do is we make a variable called ray of type ray, and this is the key point. We say given the mouse position, the input mouse position on the screen in this viewport, do a screen point to ray, okay, on the camera. So we use the camera to turn the screen point into a ray. And what that does is it sends a ray straight into the world, straight orthogonal to the camera, right angle, straight through the screen, like you're sticking a pencil through the screen. So that's what that does, and it produces a ray. Now, another fun and interesting thing here, this is something called an out parameter. We're going to declare something called hit, of type raycast hit, but we're not going to use it right now. We do it on the next line. And what we do is we call physics.raycast, which is a static method of physics, and we pass it in the ray. We say, hey, physics.raycast, use the ray we just told you about that fires straight through the camera, straight into the screen. Put the result you get, and I hate out parameters, and I'm not going to rant about them here. If you want to hear a rant about out parameters, go and see the Unreal course. You'll find a lovely rant about out parameters. But it's how Unity works. So what it's doing is it's putting the result into this variable we just gave it. Even though it's being passed as a parameter here, it's a bit weird, I know, but it's how it works. You provide it a maximum distance to continue raycasting and a layer mask. Then you ask the question, if that worked, if I have a hit, return the hit, otherwise return nothing. The final thing you need to know about this weird raycast for layer method is, what's this raycast for hit question mark? That's interesting. That there is a nullable parameter. What it means is this method is supposed to return a raycast hit. It does most of the time, but some of the time it's going to return null. If you didn't do that question mark, then it's not going to let you return null. You see here, cannot convert null to raycast hit because it's a non-nullable value type. Raycast hit is non-nullable itself. It's a value type that can't be made into null, so you use a nullable parameter. Not, again, super nice, but you'll see a lot of this in Unity's documentation. That's why I've done it this way in our project, because it's pretty standard. So take a look at camera raycast hit yourself, import it, attach it to your main camera, and now I've got a little challenge for you, which is I want you to actually use it to make sure you understand it. So write cursor.cs and attach it to the camera. Print the layer of the object you're clicking on, that's your challenge, and use camera raycaster.cs that we've just introduced. So see if you can do that. See if you can get cursor.cs to just use the camera raycaster, go find it as a component, and see if you can print out the layer to the console, and that will do us for this video. Okay, welcome back. Let's see if we can do that. So I'm going to add a new component, a new script called cursor. There it goes, and I'm going to just go into cursor. First thing we need to do in cursor is give ourselves the access to a camera raycaster. There it is. Let's not call it anything more complicated than camera raycaster. Very boring, I know, but let's do that. And let's go find it. So with a component architecture, this is very normal. Now, how are we going to find this camera raycaster? Small c, it's a variable. How are we going to find it? Well, we're going to find component by type, aren't we? We're on this script. It's another component on the same game object. So we're just going to get, is it get or find component by type? I think it's get component. Yeah, get component's all you need to do. Of type, camera raycaster. No parameters required, and that's that. So we've got the camera raycaster. All I want to do now is when I actually click the mouse, I want to know where, or maybe not when I click the mouse actually, that's a bit of a big challenge. How about just all the time for now? We don't have to put it down to reading the input. If you've done that, well done. If you've gone and queried the mouse input, it's very easy. It's just an if statement around this. But let's just start by just printing out camera raycaster dot, and then remember we exposed that layer hit over here, camera raycaster, we exposed hit and also layer hit. Let's just go straight to the layer hit. There you go, dot layer hit. Great, so we're just going to print out the layer that was hit. Let's see what this does for us. Let's play the game. Saying walkable, the number of logs against walkable is increasing because I'm in collapse mode. And then if I go over here, it's saying enemy. That's a bit strange, and that's saying walkable on the ground there. Why are we getting enemy when we hover over there, I wonder? Let's just take a look. Ah, because I assigned those to enemy. Okay, well, that'll explain it. Let's set all those to walkable and their children. You may have wondered why on earth I was setting it to enemy before. Let's try again. What do we get here? We get walkable, walkable, walkable here. What do I get? Well, it's going straight through this block, which is okay at the moment. We'll need to do something about blocks that are not walkable at some point in the future, but that's okay right now. And let's just go to the edge of the map. If there's a quick way to the edge of the map, what's the quick way? Maybe that way. And see what happens if we cast out into the end of the world. You should get Raycast end stop coming out. So if I go over the end of the world, there you go, Raycast end stop. So that shows that's working. The only odd thing is the cube that's effectively see-through at the moment, but that's it. That shows you how we do our raycasting. So I wonder how you got on with your challenge. Of course, I forgot to move my little bar along the bottom of the screen onto challenge, but eventually I'll get used to that. I wonder how you got on, and also how did you get on? Let us know in the Q&A with this idea of reviewing code. You know, this is a longer video. I'm not entirely sure how long I've been going right now in this video. I'll have a quick check over in OBS. Yeah, 25 minutes, long video. And I've reviewed code rather than writing the code, but this is a really important factor when it comes to such a big and complex project. So I'd like to know, those of you, by the way, who aren't developers, and you don't want to know about the development, you can, of course, just watch what we do and follow it, follow it exactly, and not do the coding challenges. That is always an option for you. And if you would prefer, we provided you with like full code to import, that, like for instance, the camera raycaster and the utility script, and just like make that a package you can put in, drop in, and it works, and you can leave the video and move on to the design video. Sure, let me know. But also from the developers, I'd like to know, how do you find this combination of doing some things that are new like raycasting, but also bringing in scripts? If we can work this way with you on this course, it's really going to make you more independent, more likely to build your own game, but it's also going to allow us to move a lot faster. So give me the feedback. We can always adjust things, and I will see you in the next video.